Every winter, headlines warn of the polar vortex, a phrase that conjures images of an icy monster storming south. The media loves this dramatic shorthand for extreme cold, but it's often misleading. The polar vortex isn't a single storm or a villain targeting the UK. Its fame exploded after the brutal North American winter of 2013-14, and now it's used everywhere. But the popular meaning has drifted far from the science. It's become a catch-all for any winter chill, oversimplifying complex weather systems. This confusion masks the real drivers of our cold snaps. So, what is the polar vortex really? We'll break down the science, bust the myths, and reveal what actually brings Arctic air to the UK. Understanding the real story helps us see past the hype. By the end, you'll know why UK cold waves are more complicated than a single vortex attack. We'll explore the true mechanics of our climate system. This isn't just for meteorologists, it's for anyone who's ever wondered why winter can turn so bitter, so fast. By learning the facts, we can spot media exaggeration and be better prepared. Let's leave the headlines behind and dive into the real science. The polar vortex is just one piece of a much bigger puzzle. To understand our winters, we need to look at the whole atmospheric system. Let's get started. The truth is far more fascinating than the fiction. The polar vortex isn't a storm you can see on a weather map. It's a vast, persistent swirl of cold, low-pressure air high in the stratosphere, 10 to 50 kilometers above ground. There's one over each pole, strongest in winter, always present. Think of it as a spinning top of winds circling the pole, trapping frigid air inside. When the pole tilts away from the sun, the air gets even colder, powering up the vortex. A strong vortex keeps Arctic air locked up north. But sometimes, the vortex weakens or wobbles, often after a sudden stratospheric warming, or SSW. During an SSW, stratospheric temperatures can soar by 50 degrees in days, disrupting the vortex. The fence breaks and cold air can spill south. This chaos up high can, after a delay, trigger extreme cold at the surface. The key link. The polar vortex influences the jet stream, the fast-moving river of air that steers our weather. When the vortex is disturbed, the jet stream can become wavier, letting Arctic air reach Europe and the UK. So, the polar vortex sets the stage, but it's not the whole show. The real action happens when these upper-level changes ripple down to where we live. That's when we feel the chill. A common myth. The polar vortex is a storm that hits the UK. News reports make it sound like a blizzard marching south, but that's not how it works. The vortex itself never leaves the Arctic stratosphere. What we experience is the aftermath, a shift in atmospheric patterns that lets cold air escape. Imagine a pond. A disturbance at the center sends ripples outward. When the vortex weakens, it's those ripples, changes in pressure and wind, that push Arctic air south. The UK's cold snaps aren't the vortex arriving. They're the result of displaced cold air, steered by the jet stream. The real story: a weakened vortex creates conditions for Arctic outbreaks. But it's not a storm on the move. The media's vortex attack headlines miss the complexity. The polar vortex is a global-scale feature, not a local event. The cold we feel is just one small part of a much bigger atmospheric shift. It's time to retire the myth of the polar vortex as a travelling storm. Another myth. A weak polar vortex means the UK is doomed to freeze. In reality, a weakened vortex only increases the odds of cold. It doesn't guarantee it. The atmosphere is chaotic. Many factors decide where the cold goes. After a sudden stratospheric warming, it can take weeks for effects to reach the surface, and sometimes they miss the UK entirely. For a true cold snap, we need a blocking high over Scandinavia or Greenland to steer Arctic air our way. Many SSWs bring little change to the UK. The beast from the east, in 2018, was a rare perfect storm. A weak vortex loads the dice, but doesn't decide the outcome. It's just one ingredient in a much bigger recipe. The real driver of UK winter weather is the jet stream, a fast-flowing river of air high above us. It separates cold polar air from warmer southern air, steering storms and pressure systems. Normally, it brings mild, wet weather from the Atlantic. But when the jet stream becomes wavy, it can block that mild air and open the door to Arctic blasts. A weakened polar vortex makes a wavier jet stream more likely. If a blocking high forms over Scandinavia or Greenland, it diverts the usual flow and pulls in cold air from the north or east. This is the classic setup for a UK cold snap. The sequence vortex weakens, jet stream wobbles, blocking high forms, Arctic air arrives. The final step, where the high and low pressure systems set up, decides if we get the cold. The polar vortex is just the first domino. The jet stream and surface patterns do the rest. That's why not every vortex event brings a freeze. It's all about the atmospheric chain reaction. The media loves dramatic headlines about the polar vortex, but reality is more nuanced. Sensational maps and phrases like Arctic blast grab attention, but often oversimplify. These stories can make it seem like a deep freeze is certain, when it's just one possibility. Meteorologists use ensemble forecasts, dozens of model runs, to gauge risk, not single dramatic predictions. The timeline is often exaggerated. Effects from a stratospheric event can take weeks, not days. The beast from the east was a rare alignment, not the norm. Constant hype sets unrealistic expectations and erodes trust when the cold doesn't arrive. Most SSWs don't lead to UK deep freezes. Understanding the science helps us see past the headlines. The real story is always more complex than the news suggests. Not every cold UK winter is caused by the polar vortex. Regional weather patterns play a huge role. A southward shift in the jet stream can bring Arctic air without any stratospheric drama. The North Atlantic Oscillation, NAO, is key. When it's negative, blocking highs form and cold air flows in. Sometimes, a simple northerly wind after a North Sea low brings snow and chill. High pressure over the UK can trap cold air, causing frosts and fog. These are normal parts of our climate, not signs of a vortex collapse. UK winters are shaped by many factors. Most have nothing to do with the polar vortex. It's a complex mix, not a single cause. To avoid weather myths, check your sources. Trust official meteorological organisations, not sensationalist headlines. Watch for dramatic language. Terms like vortex attack or snowmageddon are red flags. Good forecasts explain the science, mention probabilities, and discuss the jet stream and pressure systems. Be wary of long-range predictions based on a single model run. Reliable sources emphasise uncertainty and trends, not certainties. Cross-check stories with official channels like the Met Office. Look for consensus among experts, not just the loudest headline. Being informed means being prepared, not scared. The polar vortex is real, but it's not a storm attacking the UK. Its influence is indirect, setting the stage for cold, but never guaranteeing it. The real architects of our winter weather are the jet stream, pressure systems, and the North Atlantic Oscillation. UK cold snaps have many causes, most unrelated to dramatic vortex events. Media hype can distort the science, but understanding the basics helps us see through it. By seeking out good sources and learning the real mechanisms, we become smarter weather watchers. The next time you hear polar vortex, you'll know to look for the real story. Knowledge is the best defense against winter weather myths.